ऐगिरिनन्दिनि नन्दितमेदिनि विश्वविनोदी नन्दनुते गिरिवरविन्ध्यशिरोधिनिवासी विष्णुविलासी जिष्णुनुते ऐगिरिनन्दिनि नन्दितमेदिनि विश्वविनोदी नन्दनुते गिरिवरविन्ध्यशिरोधिनिवासी विष्णुविलासी जिष्णुनुते.
High performance computing covers is mostly about like computing, like related to computers, but basically it spans across different industries, which covers like oil and gas, energy, manufacturing, climate, drug research. So all these industries, they need computing resources. And high performance computing caters to computing resources that all these industries need. Now, like for example, if somebody's designing an aircraft, then they have to run some extensive simulations or extensive CAD CAM applications, and they would run on either a big supercomputer or big data centers. So high performance computing is about that, how to enable all these industries to make use of computers. So high performance computing has been there for several years now. And this was traditionally based on scientific equations that have been translated into software programs. But now with artificial intelligence, the way it's becoming, the way artificial intelligence has made its way into the consumer side of the business, the high performance computing engineers are looking at if they can use the same techniques for doing the work that they were doing. So I'll give you an example on how this intersects. So for example, in this slide, I'm showing a simple use case where the AI algorithm is trying to recognize and outline where the biker is in this picture. So they would train a computer program by feeding it a lot of images so that the computer program learns to identify where the biker is, what the background is, and what's the bicycle. Now, once this model in the middle is trained, the AI model is trained, it can also be, if it is trained on different images, it can be used to identify different kind of objects. So in high performance computing, they're looking at how to use these kind of models for doing their work. So big example is we are always, concerned about, what the weather is going to be like and, where the storms are going to come. So these satellite images are there, which take the image of the whole globe. So if there were AI models that could recognize in the satellite images, where the storm is forming, how it is moving, it can help in providing that information sooner to the community. And also dispatch, if any risk mitigation needs to happen or some rerouting of flights need to happen. So all that information can be shared much more faster. So they're looking, when they say HPC plus AI, is how to get these AI techniques to solve HPC problems. So AI has been used for drug discovery, and it's also being used for material science. So when it's used for material science, it is used to figure out like new kind of materials that can be used, for example, for designing a battery. So the same technique, since material science is also dealing with chemicals and compounds, the same techniques can be applied for finding out, what could be good drug candidates. So before, they set up the wet lab to test those candidates, they can actually test them using software programs so that they don't have to do, a million tests in the lab. They can identify maybe these 1,000 candidates are the good ones and only those we need to test. So they're using AI techniques to help in identifying those like few compounds that they should test in the wet lab. I spent a lot of my childhood years with my grandfather, and he was a civil engineer and he was from Roorkee, and he was involved in, the very first constructions of dams and the roads that were constructed in UP. So I was very much, I spent my summer vacation with him. So I was very influenced by, how he used to build things. And then my dad is being a mechanical engineer. So, I just thought that engineering is the profession. So I ended up joining IT, and I ended up going into mechanical engineering because I felt that, I felt like, building something is what came naturally to me because that's what I had seen growing up. So that's how I got into mechanical engineering. And then later on, yes, industry evolved. So I got into the product management side, and I'm very happy that even though I'm doing computer science related stuff, I'm doing AI, but I still get to use some of the learnings I did during my mechanical engineering days. I would say that computer science is really a great tool. And just like, there are several tools in a toolbox, in today's world, computers or the power of computing is like a tool available to them. So people don't have to do a lot of calculations manually, and especially, when they're trying to simulate designs. So I would say knowing about computer science is very helpful as a tool to know, but along with it, having domain expertise is also important. So for example, if somebody is doing chemical engineering, they should, having the background in chemical engineering and then combining it with computer science is a very good combination, because I feel that somebody still needs to know what is like the pure science or the pure domain, and always be somehow stay in touch with that. And then computer science is a new tool, and learn how to use that tool to solve a problem in your domain. I would say that, if I define like a strength in a woman, that would be a better way, how I interpret it. And I feel that having somebody who's resilient and has grit, I would say that that person or that woman is very strong, because it's a long life. There will be ups and downs, there will be success and failures, but the ability to just plow through them and to be resilient versus any obstacles, I think that I would define as strength in a woman.
I